Okay, so let's work problem number 59 of the 1988 E&M multiple choice AP Physics C exam. I'll read the problem. A negatively charged particle in a uniform magnetic field B, moves with a constant speed v in a circular path of radius r as shown above. Which of the following graph best represents the radius r as a function of the magnitude of b if the speed v is constant? Okay, so this is kind of a freely moving charged particle, and you have F equals Q V cross B. I mean, you have to have this memorized. This is a big idea right here. Okay, and now notice that it's V cross B, and the right-hand rule says you cross one vector over to another, and your thumb will be the direction of a force on a positive charge. So look at V is to the right, so I move my right fingers to the right, then I cross them into the page, and my thumb is pointed up, right? So why is this going in a circle like this? Because it's a negatively charged particle, so the force is down like that. And notice that no matter where I am, the force is going to be pointed towards the center of that circle, which means that this force is a centripetal force. So this is mv squared over r. This is a very, very common thing to, and by the way, the cross product v cross b, you can just go qvb equals mv squared over r. Okay, now what does it want? It wants which of the following best represents the radius r as a function of b? So we want to solve for r as a function of b. Well, let's cancel out what we know here. And we're going to solve for r. So I'm just going to take this equation and solve for r. So r is going to be equal to mv over qb. So r is a function, well, m and v and q are all constant, right? It's a function of 1 over b. So we're looking at an inverse function. So r is inversely proportional to b. So we're going to look at our choices here. And notice that, well, it's not a constant, right? I mean, r does change with b. If I increase the magnetic field, I'm going to change the radius of that circle. So A is out. Now B looks like an inverse graph, doesn't it? So B looks like it. Now this is not an inverse graph, and this isn't, and so these are all gone. So the answer is B. So this is a common kind of a thing where they're going to ask what is, at least on the multiple choice test, they're going to ask, what kind of relationship does it have? And you should recognize this. If you solve r as a function of b, and then you say, oh, all this stuff is a constant. Well, r is equal to some constant stuff times 1 over b. That's an inverse relationship. You remember for math, y equals 1 over x. Well, if you graph y as a function of x, it's, what is it, like this? And I think if x is negative, it looks something like that. But we don't care about the negative stuff. We're just over here. Okay, so what are the big ideas here? Big ideas. A free moving charged particle in a magnetic field. Well, the force on it is QV cross B. Remember, if they give you a negative charge, the force is just in the opposite direction from V crossed over to B. Right? Negative charge gives you a negative. But that force, if it's a free moving charged particle in a uniform magnetic field, that force is constant, and it's always perpendicular to your velocity vector, which means it's a centripetal force. So you can set the force equation equal to the centripetal force equation and solve for whatever you want. Make sense? Any questions? Okay, that is all.